Dr. Babasaheb Ambedkar Open University.
Namaskar, dear students and learner of this course. I am Professor Kamesh Rawal. I welcomes you in the video lecture series of Dr. Babasaheb Ambedkar Open University. I think in the last session we have seen what different type of numbering systems are there, right? So we know that there are 4 numbering systems are there. One which machine can understand, it is known as a binary numbering system. One more number system is there in which we are using 8 symbols, that is called octal numbering system, right? Then the number system which we are using for our daily transactions, right, day to day transactions, it is known as a decimal number system, right? In the decimal number system we are using 10 different symbols to represent a particular digit. Okay. Then one more number system is there which is known as a hexadecimal number system. So I think in the last session we have seen what actually the hexadecimal number system is there and how many different type of symbols are there, right? Total 16 symbols are there, and that's why we can say the base of the hexadecimal number system is a 16. Okay. Now in this session what we will do is we will just try to see how can we convert any hexa number is given to you, right? And suppose if you want to convert it into the octal number system, or suppose any octal number system octal number is given to you and you want to convert it into the hexadecimal, then what thing that we need to do, right? In fact we have seen the different type of conversion in the last session. So in the last session we have seen, suppose if the decimal number is given to you, then how can we convert it into the hexadecimal number system, right? Suppose if hexadecimal number is given to you and you want to convert it into the decimal number system, then what to do, that we have already discussed, right? But now specifically here we will just try to learn how can we convert a particular number which is given into the octal into the hexadecimal, as well as suppose if the number is given into the hexadecimal format, then how can we convert it into the octal number, right? Along with that we will just see how the computer performs arithmetics, right? So basically right now you people might think that we are just learning this particular number system because it is there in the syllabus, but no, it's not like that, right? The things whatever is there in your syllabus is obviously used in our computer science, right? Whenever user is inputting the number, so we are never entering a binary numbers, right? But we are entering what? We are entering a decimal number, and you know that we have already discussed that thing. The machine can understand only one language, and that is a binary language. So here some sort of translation will be done, right? Whatever numbers are entered by the user in the decimal format, that gets translated into the binary format, right? So how actually the computer, suppose if I want to do a summation of two number 15 plus 20, right? So how the computer will perform that type of computation, right? How the computer will add both the number 15 and 20 and how it will return 35 to us, right? So if you want to understand all these things properly, then you should have a proper knowledge of this numbering system as well as the conversion between them. Okay. Now as we have already discussed, there are 4 numbering systems are there. Binary whose base is 2, here only 2 symbols are there, 0 and 1. Octal number system is there which will have total 8 symbols, they are 0 to 7, and due to that reason what we can say is here the base of this octal number system is 8, right? Similarly, we have the decimal number system in which we are using total 10 different symbols, right? So from 0 to 9 total 10 symbols are there, and due to that reason what we can say is this numbering system's base is 10, right? Okay. Now one more system, right, is there which is called hexadecimal. Now see, in the hexadecimal there are total 16 symbols are there. So let's suppose we will just start from the 0 to 9, right, and then A, B, C, D, E, F, right. So this much numbers you can use, this much symbols you can use to represent a single digit, and due to that reason the base of this hexadecimal number system is 16, right. Okay, now suppose one hexadecimal number is given to you, right, and you just have to convert it into the octal, right. So obviously there is no direct conversion methods are available, right. You cannot convert any hexadecimal number into the octal format directly. So how can we convert this thing? So you know that, okay, sir, you have already taught how can we convert any hexadecimal number into the decimal, and we are much more familiar with the decimal number because we are using decimal number in our day-to-day life. Okay, so first what we can do is we can convert whatever hexadecimal number is given to you, you just try to convert it into the decimal form, right. And once you have the decimal, then you know that once the decimal number is given to you, then you can easily convert it into the octal format, right. So we have seen both the conversions, right. I have already taught you that any hexadecimal number is given to you, how can we convert it into the decimal. We have also seen this thing, that is, suppose if the decimal number is given to you, then how can we convert it into the octal number, right. So here what we can do is, the first obvious method is what, here whenever the number is given to you, what you need to do is you just need to convert it into the the hexa number given to you into the decimal format. Okay, so now see, here you have a number which is given, which is called F2, right. So F2, that's we know it is a hexadecimal number system, it is a number with a 2 digit, right. So here first of all what we will do is, first there are 2 digits are there, and we know that how can we convert it into the decimal form. So here the digits are what, F and 2, right. So obviously we are just starting from the last digit is 2, and what we will do is we will just try to multiply that 2 with 16 to the power 0, right. The last digit should have a power 0. Similarly F is the second digit, so second digit has to be multiplied with the power 1, right. And here we are using 16, that is because of we are converting hexadecimal number into the decimal format, right. So we know that the base of the hexadecimal system is 16. So here you need to multiply 2 with 16 to the power 0 and F with 16 to the power 1, right. Okay, now we know that 16 to the power 0 is what, it's 1. So 2 into 1 and F into 16. Why? Because 16 to the power 1 is a 16, right. Now in the third step what we have done is F represent which number? F represent 15, right, because we know that from 0 to 9 we are using 0 to 9, but 10 will be represented as a in the hexadecimal, 11 will be represented as a B, 12 will be represented as a C. Similarly F is represented as a 15. So now here you can see 15 into 16, it will make 240, 2 into 1 it is 2. So the final answer is what, 242. Now here what we have done is we have converted the given hexadecimal number into the decimal, right. Now this decimal, actually what we have to do is we have to convert the hexadecimal into the octal, not the decimal, right. But first what we have done is we have converted hexadecimal number into the decimal form. Okay, now once you have the decimal number, right, then what you need to do is you just need to divide that decimal number by 8 and you have to collect all the remainders, right. We know that how can we convert a decimal number to the octal. So see, F2 will represented as a 242 decimal number, and now we want to convert that 242 decimal number into the octal. So obviously we will just try to divide that 242 number by 8, right. So first of all we are just dividing by 8, so we are getting 30, but 30 into 8 is 240. So 2 is a remainder that we have returned, that we have returned here. Okay, then again 8, right. So 8 3s are 24, but we need to bring 30. So 30 minus 24, so 6 remainder, that is here. Okay, now 8 you know 8 1s are 8, but here we need to bring 3, 8 is more than 3, right. So here we will just write 8 zeros are 0, so whatever thing is here it will be a remainder, so that is 3. Okay, so you need to write down the remainder into this way, so that is 3, 6 and 2. Okay, and this is what we can say it is our answer, right. So here suppose if the number f2 is given to you, then first what you can do is you can convert it into the decimal form, and then you divide that decimal number by 8 every time unless and until you are not getting 0 here, and then you write it down all the remainder, so you will get 362 octal. So the answer is what? 362. F2 hexa number, it is equivalent to this 362, right, octal number, right. Okay, but the thing is, you know, it is little bit complicated, right, because the thing is, you know, once we are having suppose hexadecimal number, then we are converting it into the decimal form, then again we are finding octal from that decimal, so it is a little bit complicated, right. Is there any other easiest method or easier method is there? Yes, obviously. What you can do is, see, we have already discussed that whenever you have the hexadecimal number, you can represent that number by using 4-bit, pair of 4-bit, right. So here what we have is, we have a 2. Now how can you represent this 2 in the hexa form? In this way, it is 0 0 1 0, right. This is something, let's suppose we want to represent 2, okay, we want to represent 2, fine. So here I will just start with, and for this 2 I will write it down by using 4 bits. Okay, so these are the 4 bits. Okay, now 4-bit. So this will represent, last bit will represent 1, this second bit will represent 2, third bit will represent 4, and this will represent 8. So do you need 8? Obviously not, right, because 8 is, you know, it is greater than 2. So here we will put 0, right. Okay, now here this bit represent what? 4. Do you need 4? Obviously not, because 4 is already greater than 2. So here we will put 0. Okay, then do you need 2? Yes, we want 2. So here we will write 1. Now see, you have taken 2 and here the number given is 2. So 2 minus 2 is 0. So nothing is remain, right. So here do you need 1? Obviously we don't need 1, right, because the thing is the number is completed now, right. So this is what we can say, it's a binary of 2. Similarly, let's suppose if f is given to you and you just have to compute a binary of it. So what we will do is, f means what? That you should know, f means it represent 15. So let here what we have is, we have 15. Okay, 15 is there. Okay, now see here I will just mention the 4 bits. So this is 8, 4, 2 and 1. Okay, so first we will just start from this. First bit represent what? 8, right. So do you want 8? Yes, we want, because 8 is a smaller than 15. So I have taken 8. So now you just subtract 8 from 15, right. So that is what it is, 7, right. So 7 remains. Okay, now this bit represent what? 4, right. So we'll take 4, right. So 7 minus 4, now 3 remains, right. Again we will take 2, right. So 3 minus 2, okay, so that is 1. Again we will take 1, so 1 minus 1, the number will convert it to 0, right. So here f is what? F represent 1 1 1 1 binary, right, and that is what I have returned, right. So the binary of f is 4 times 1 and the binary of 2 is 0 0 1 0. Now see, here we are using a pair of 4-bit, right, because the number given, that is in the hexa format, okay, hexadecimal format. Now we have to convert it into what? We have to convert it into the octal, and we know that octal represents how many? 8 bits, right. In the octal number system what we have is, we have 8 symbols, right? And how can we represent it? So 2 raised to 3. So to represent any one digit of a octal number, you need a 3 bit, because 2 raised to 3 will make 8. So see, now this hexa binary, you need to convert it into the octal. So now what we will do is we will make a pair of 3 bits. So you just start from the last. So here you just make a pair of 3 bits. So the first pair is 0 1 0, right? Then make a second pair, that is 0 then 1 1. Okay, so this is 0 1 0, 3 bit pair, then this 0 and double 1. Now this 2 1 remains, so you just write it down, that 2 1s here, right? Now what actually we wanted to do, we want to make a pair of 3 bits. So here we can successfully make a pair of 3 bits. Here again we have made a pair of 3 bits, but here only 2 bits are there. So how can we make a pair of 3 bits? By adding 1 0, right? So you can add 1 0 at the left hand side. We know that in the numbering system, if we are adding a 0 at the left hand side, it doesn't make any kind of change into that particular number. Now see, you just see that table in which we have returned the binary of all the octal symbols, right? Or you can also count like this. This is 1, this is 2, this is 4, right? 1 2 4, right? So here 1 is not there, 4 is not there, only 2 is there. So this is what it is, a binary of 2, right? This is the binary of 2. So that we have returned here. Now again this is 1, this is 2, this is 4, right? 1 2 and 4. Okay, 1 is not there, but 2 and 4 is there, because at the place of 2 and 4 we have 1 1, right? At the place of 1 what we have is, we have 0. So 4 plus 2, that will make what? 6. So here we have 6. Now again 0 1 1, so this is 1, this is 2, this is 4. So 4 is not there, but 2 and 1 is there, so 2 plus 1 will make 3. So this is what it is, the octal number. So see, this is the bit easier method, right? Whenever any hexadecimal number is given to you, what you do is you just make a pair of 4 bits, you just write it down a binary, and in that way you have converted the number into the binary. Now once you have the binary of whole hexadecimal number, you try to make a pair of 3 bits. Make sure you just have to make a pair of 3 bits from the right hand side, right? And you have to go towards the left hand side, okay, into this way. So 3 bits, you just write it down here. Again 3 bits, you just write it down here. Again whatever remaining bits, that you put it here. Then suppose here there are only 2 bits are there, you append 1 0. Suppose here only 1 was there, I will append 2 zeros, right? You can add as many as 0 at the left hand side, and then convert this 3 bits pair into the decimal form, right? Or octal form, and you will get the octal number, right? So this is more easier than the previous method. See, this is what we can say here, all hexadecimal symbols are there, and we know that to represent any hexadecimal, we need to write a pair of 4 bits, right? Because 2 raised to 4 is 16, and in the hexadecimal system what we are doing is we have a 16 symbol, right? Let's suppose if you have a pair of 3 bits, then by using this table you can convert it into the octal form, right? Here we are using a pair of 3 bits. Why? Because the thing is, there are total 8 symbols are there in the octal numbering system. Okay, let's suppose here 2CA, this is what the hexa number which is given to you, and you have to convert it into the octal number, right? So what you will do is you just consider this 2 and write the binary of 2 here in the pair of 4 bits, because this is a hexa number. Then C, so C will be represented as a 1 1 0 0. A is a 10, and how can you represent 10? 1 0 1 0, right? See, it is something like A represent 10, okay? And here what we have is, we have a 4 bit. So this will represent 1, this will represent 2, okay, then 4. You just have to double every time, right? And the last bit will represent what? 8. Now what I am having is, I am having 10, right? You just start from 8. So, will you consider 8? Yes, we will consider, because the thing is, 8 is a smaller than 10. Now, what you have to do is you have taken 8. So, 8 you need to subtract it from 10. So, now how much you have? You have only 2. Okay, fine. Then will you take this 4? Obviously not, because 4 is already greater. Here our number is what? 2. Okay. Then suppose 2. Will you take this 2? Obviously yes, because we want 2 here, right. So, 2. So, I am just taking 2, and 2 minus 2 is what? It is 0. So, now our number turns to 0. Now, we do not need a 1, right, because our number is already converted to 0. So, here we will put 0, and this is the way we can convert any number into the binary format. So, here 1010, right, which is actually a representation of A. This is the representation of C, okay, and this is the representation of 2. Fine. Now, what we need to do is we need to make a pair of 3 bits. So, here you just see last 3 bit is what? 0 1 0. So, that is we have returned here. Then this 1. So, this 3 bits 0 0 1. So, this 0 0 1 we have returned here, right. Then this 0 1 1. So, that 0 1 1 we have returned here, and finally, what is remain? It is 001, right. So, that 001 I have returned here. Now, 001, you look at to this table. Just a minute. Look at to this table. 001, it is an octal number of what? 1, right, 1. So, here we have returned what? 1. Similarly, if you are going through that table, you will understand this is the binary of 3, this is the binary of 1, this is the binary of 2, right. So, this is what the octal number. Fine. Now, how can we convert any octal number which is given to you into the hexadecimal? So, we just have to repeat the same process. Let us suppose if this 1312 octal number is given, right. So, what we will do is, we know that to represent any octal number, any octal digit, we need a 3 bits, right. So, I will just write the binary of this 1 in a 3 bit pair, right. I will write a binary of this 3 into again a 3 bit pair. I will again write a binary of this 1 into 3 bit pair, and again this 2 is there. So, we will write it down into the 3 bit pair, it is 0 1 0, right. Now, we have to convert this octal number into the hexadecimal. So, in a hexadecimal, one digit will represent 4 bits. So, now you need to make a pair of 4 bits, right. So, I will just consider this 4 bits 1010, okay. So, that I have written here. Then from here you can start, again you count 4 bits. So, it is 1100. So, that 1100 I have written here. Again this 0010. So, that I have written here, right. Now, this will represent what? 1 is not there, but 2 is there, 4 is not there, 8 is not there. So, it is 2. Okay. Now, 1 is not there, 2 is not there, 4 and this 8 is there, 8 plus 4, that will make 12. How can we represent 12 in the hexa? By writing C. So, C. Now, here you see 1 is not there, 2 is there, 4 is not there, 8 is there, right. So, 8 plus 2, it will make 10, and how we are writing 10 into the hexadecimal? By symbol A. And in this way, what you can do is, if any octal number is given to you, you can easily convert it into the hexadecimal, right. So, this is by mistake, and I have written 8, but here 16 has to be there, right, because this is a hexadecimal number, right. Okay. Now, you just try to convert, this is the octal number which is given to you, and you just need to convert it into the hexadecimal, right. So, 4 will be represented as 100, right, because 1 is not there, 2 is not there, 4 is there, right. So, 4. How can you write 6? So 4 plus 2, right? So 4 plus 2. So 1 is not there. So this is what the binary. Now what you need to do is you need to make a pair of 4 bits. So I am just considering the last 4 bit. It is 0110, right? So 0110, and whatever things are there, that is 10, that 10 you write it down here. Now to complete the pair of 4 bits, what we are doing is we are appending 2 more zeros, right? Now this is a binary of which hexa digit? It is a binary of 2 hexa digit, and this is the binary of 6 hexa digit, right? So 46 octal will be converted into the hexadecimal, and for that you need to write 26, okay? Suppose here 72 octal number is given and you have to convert it into the hexadecimal. So 7 will be represented as 4 plus 2 plus 1, right? So that is 7, and 2 will be represented in a manner that is 010, right? 4 is not there, 2 is there, and 1 is not there, right? So this will represent what? 2. Okay, now you need to make a pair of 4 bits. So what I am doing is I am just considering this 1010. Okay, so 1010 is here. Now here 2 ones are there, so 2 1, but to complete the pair, what we are doing is we are appending 2 zeros at the left hand side. Now see what is the binary of this? 0011, it is a binary of 3 hexa, right? 1010, it is actually binary of 10, but 10 we are writing by symbol A, right? So this is what? This is again it is a hexadecimal number of the given number, right? This is not 10, this is 16. Okay. Now see, we will just try to understand how actually the computer is processing the thing, right? As being a user, let's suppose if you want to do addition of 2 number, what you are doing is as a user we are inputting this thing, right? We want addition of this 21 plus 18, right? But see, whenever you are inserting this numbers with plus operator, this plus operator will be converted into the opcode. It is some binary code will be there for each and every operator, right? If you are using plus or minus or multiplication or division, or suppose if you know the C language, then in the C one more operator we are using to find it out the remainder, that is a modulo operator, right? Percentage operator. So whatever operators you are using, that has a specific binary code, and it is a unique code, right? So that is called opcode, which is again you need to understand in the form of binary. Then what is your first number? It's a 21. So what computer will do? You are entering 21, but the computer, computer cannot understand decimal number, right? Why? Because the thing is, we know that our computer is working in the form of ICs, right? So in the hardware of the computer, in the memory, what we have is ICs. IC stands for integrated circuits, and these are having a million and billions of small capacitors, transistor kind of devices, right? And what we can do to these devices, we can charge or we can discharge. Suppose if you charge this particular transistor, then electron is present. If electron is present, it will represent 1. If you discharge it, the electron is absent, and in that case we can say it is a 0. So see, in the computer's memory we can't put this 21 or 18 or something like that, right? In the computer's memory we can just store only the binary. So whenever you are giving any decimal number, the computer just convert that numbers into the form of binary like this. Now this binary will be taken by the CPU, right? First, the CPU will have a control unit. So the role of the control unit is what? It is just reading the opcode, which operation that we need to perform, right? Here the opcode is of what? It is a plus sign. Plus means addition. So here once the computer, this CPU's control unit will recognize here we need to do the addition, CU is sending one signal to the adder circuit. Now where is adder circuit? It will be there in the special section of the CPU, which is known as ALU. ALU, that we know, it is a arithmetic and logical unit, right? So the CU is sending one signal, so adder will gets activated, and then we are passing, the system will pass 2 numbers which is there or stored in the random access memory in the form of binary, and here the CPU will generate this type of output, right? So again the output is what? It is in the form of binaries, right? Finally, what happened, this binary gets translated into the decimal form. So finally, you know, by the output devices, and here on the screen 39 gets printed, and which is you know, that user can see as a output. Fine. So see, user is inputting a decimal number, user is getting output into the decimal number, but the numbers, the data, whatever is entered by the user into the system, that get processed in the form of binary. And that's why, you know, we have done a detailed discussion on all 4 different type of numbering system. Later on in the later session, we will discuss how can we perform addition, how can we how the computer is doing a subtraction with the binary numbers, right? So we have discussed how can we convert any hexadecimal number into the octal numbering system, as well as suppose if the octal number is given to you, then how can we convert it into the hexadecimal. In the next session, we will just comes up with a new topic. We will see how can we do the addition of a binary numbers, right? Till then, take care and bye bye.